To continue our discussion of respiratory protection. In the last module, we went through an overview of respiratory selection procedures, the process of selecting the right respirator. Again, just an overview. We talked about APF, which is the assigned protection factor, and we talked about MUC, which is the maximum use concentration. In this module, I want to go into more detail, give you some detailed problems, respirator selection problems, and again, I really want to understand this process before we're through with this unit because it can be important. But there was one thing in the last module that I told you I would get back to you on. That was this chart with all the APFs for the different types of respirators, and this is correct. If I went back to the original OSHA chart, and that is correct. But this is demand mode positive pressure. Demand mode positive pressure, you're talking about situations where you're not going to use the helmet or the hood. There is no APF for demand mode positive pressure for a helmet or a hood. Now, continuous flow, you're also talking about positive pressure there. And that's where you're going to see the use of a helmet or a hood. And again, like we talked in the last module, if you got continuous flow, positive pressure, your APF is going to be 25 unless you have research documentation from the manufacturer stating that it is 1000 APF and has been tested. It has been tested to that standard, to that level. So again, the continuous flow positive pressure systems in most environments that I've worked with a hood work really well. So, but again, that's something to consider. You got to make sure you have the correct APF. There are going to be some toxins in some work environments where 25 APF is not good enough. Now, if you can get it all the way up to 1000 APF, then you're probably going to be covered. But just wanted to go back and clarify that question from the last module. Okay, let's look at some specific respirator selection problems. We have a worker working in an environment where they're exposed to xylene. The area is naturally ventilated, but the concentration level is still 675 parts per million. What type of respirator is required? First thing we'll need to do is find the PEL for xylene. And we're going to use the PEL. We could use the TLV or the REL, but we're going to use the PEL. The PEL for xylene, which is an 8-hour PEL, is 100 parts per million. We already know what the concentration level is, but we want to use the concentration and the PEL to find the required APF. Again, this is the hazard ratio. And let me go ahead and put in the correct terminology here. Hazard ratio. The hazard ratio is going to tell us what APF is required, but hazard ratio is the correct term for what we're doing in this step. Again, we take the concentration, 675 parts per million, divide it by the PEL, which is 100 parts per million. That tells us that we need a 6.75 APF or greater. In the required APF, the hazard ratio is 6.75. We must have a respirator that's 6.75 or greater. Again, most of your respirators, all your respirators that are commonly used in this day and age start at 10, an APF of 10. But you also need to make sure that you are matching the type of contaminant to the type of cartridge or filtration that you're using. Is xylene an acid gas, an organic vapor? Is it a particulate? When we do research on this, and you can look at different sources, NIOSH might be one. There are others also, textbooks. The back of your textbook that we have for this class has information about different chemicals also. But there's a wide variety of resources you could use to find out that xylene is an organic vapor. So we need an organic vapor cartridge in a respirator having an APF of 10. A half-mask passive air purifying respirator with an organic vapor cartridge will be adequate. Now, if we needed to, we could go with a different respirator having a higher APF. And I'm not showing the chart here, but that chart showing the APFs for all the different types of respirators, you would be using that when you went through this kind of respirator selection problem. Another thing that you need to consider is your maximum use concentration and the IDLH level. The IDLH for xylene is 900 parts per million. Now the MUC in this situation would be 1,000 parts per million. We have an APF of 10 and a PEL of 100. That gives us an MUC of 1,000 parts per million. But the IDLH is 900 parts per million. That means if once you get to 900 parts per million, you've got to use a respirator suited for IDLH conditions, immediately dangerous to life and health conditions. And that is an SCBA with an APF of 10,000. Now we could have also just used the NIOSH Pocket Guide for this problem. What we have here is information for M-xylene or O-xylene. The respirator recommendations are exactly the same. Up to 900 parts per million, you could use any chemical cartridge respirator with an organic vapor cartridge, APF equals 10. If you want to go a little more conservative, make sure you're providing plenty of protection, you could go with powered air purifying respirator with an organic vapor cartridge. You could use a supplied air respirator. You could use any self-contained breathing apparatus with a full face piece. So you got a lot of options. But the most cost-effective option is going to be the half-mask respirator with an organic vapor cartridge. Now, we also have information about emergency situations or escape situations, what would be needed in terms of a respirator. And this is, let me go ahead and mention this, emergency or planned entry into unknown concentrations or IDLH conditions. If we don't know the concentration or it's IDLH, we're going to talk about that particular problem as we go along. Now, you need to know your exposure level. If you don't know the exposure level, if you don't know the contamination, that's IDLH. That's when you need, I'm going to put my pen in the highlighter mode here. That's when, if you don't know the exposure level, that's when you need APF of 10,000, which is going to be a self-contained breathing apparatus that has a full face piece and is operated in a pressure demand or other positive pressure mode. Okay, let's look at another situation, another problem. A worker is in an environment where they're exposed to dichloroethane. The concentration level is 2,300 parts per million. What type of respirator is required? Go to the NIOSH Pocket Guide and find information for dichloroethane. And when we find this information, 2,300, again, we know our exposure level, so this really, we only have one option. Up to 2,500 parts per million, it's recommended that an APF equals 25 supplied air respirator operated in a continuous flow mode. That's what would be required in this situation. None of these other options are on the table. Are air purifying respirators recommended with dichloroethane? Okay, there are no recommendations for air purifying respirators, even in concentrations less than 1,000 parts per million. So the answer to that is no. That's a type of question you want to ask also as you're making these determinations. Again, this is from the NIOSH Pocket Guide. In IDLH level, 3,000 parts per million. If we're above that, this tells us what to do. If we're above IDLH conditions, APF 10,000, self-contained breathing apparatus. All right, let's look at another problem. Stoddard solvent is a chemical compound used in the dry cleaning industry. Worker exposure is 15,000 milligrams per cubic meter. What type of air purifying respirator is recommended? Again, we can go to the NIOSH Pocket Guide. Stoddard solvent's in there. And what are the options? Okay, this is up to 3,500 milligrams. This is 8,750. So neither one of these will work. We're going to have to go all the way up into this to this level. 15,000 is less than 17,500, so we're good to go. We've got several options available. And you want to choose the option that would be most financially feasible or most cost effective, and that's going to be any chemical cartridge respirator with a full face piece and organic vapor cartridge. I mean, you can look at the others, you can price the other ones also. That's one thing we don't do enough of in our program, I don't think. The role of a safety manager, a job of the safety manager a lot of times is budgeting and purchasing materials at the best price. So we've got to be cost conscious also. Unless we're working for the government, then it doesn't matter. We can just spend whatever we want to. It's not our money. We can spend somebody else's money. But if we're working for a private company that's trying to keep costs down, part of our responsibility is choosing the most cost-effective equipment that will still get the job done. So compare prices, compare suppliers, shop for the best value. Okay, at this level of exposure, would loose-fitting respirators of any type be recommended? No. At this level, an APF of 50 is required. The highest APF for loose-fitting respirators, a hood or a loose-fitting mask, is 25. You got to have 50 when your concentration is this high, 15,000 milligrams per cubic meter. Oh, and one thing that I'll go ahead and go back and mention just as a sidebar, my yellow marker doesn't show up on that orange background, but Stoddard solvent is a dangerous chemical that's used in the dry cleaning industry. When we think of dry cleaning, we don't think of it as being a dangerous occupation. But like most industries and most jobs, there's going to be a dangerous element to it. There are some heavy-duty chemicals that are used to dry clean your clothing, and owners of dry cleaning companies need to be aware of these. They need to do what they can to protect their workers. All right, let's look at another respirator selection problem. Now, the ones we've looked at so far, in a lot of ways, are not very realistic. This one's realistic, and this one's going to take some detective work. I'll just tell you right out of the gate, this is not going to be as cut and dried as looking up the NIOSH information. This is not going to be as cut and dried as doing a couple of calculations to figure out what type of respirator we need, what type of cartridge we need. But let's go ahead and put the situation up here. We have woodworkers at a small cabinet shop using Minwax polyurethane as a clear finish on cabinets. What type of respirator should be worn when working with solvents containing petroleum distillates? That's a hint right there. That's a hint, that petroleum distillates. We'll come back to that. But our first step could be, let's try the NIOSH Pocket Guide. Let's do a search for Minwax polyurethane. When we look in the NIOSH Pocket Guide, there's nothing for Minwax polyurethane. A next step would be to look at the SDS for the variety of Minwax polyurethane you're using. There are a lot of different Minwax polyurethanes. There's oil-based, there's water-based, there's a lot of different types. Make sure you have the correct SDS for the type that you're using in the cabinet shop. Look at the SDS. The SDS, when we look at the SDS for Minwax, and I'm not going to show you that 8-page SDS, just you have to take my word for what it's saying. The SDS does not have specific information about the required respirators, but it does identify 3 hazardous constituents. Aliphatic hydrocarbons are over 50% of the product. Zirconium 2 ethyl hexanate less than 0.4% of the product. And methyl ethyl ketoxime less than 0.4%. So now we can go back to the pocket guide. First, let's look for aliphatic hydrocarbons. The results show up when we do a search for. Let me change my pen back because it doesn't, or the highlighter doesn't show up on the orange background. So when we do a search for aliphatic hydrocarbons, we get results for naphtha petroleum distillates. Remember, I had said this was a hint up here, petroleum distillates. Now these are hydrocarbons. These are aliphatic hydrocarbons, naphtha and petroleum distillates. So that's the hazardous constituent we're looking for. Again, got to do some detective work. Got to keep digging until we find what we're looking for. So once we find that, we look at respirator recommendations for petroleum distillates. There is the NIOSH information, respirator recommendations. But we need to also determine the concentration of this substance. We can do that with different monitoring devices. We can use calculations, evaporation rate, and the volume of the space to determine the concentration of the substance. For this problem, let's just assume we're at 900 parts per million. If we're at 900 parts per million, we're going to be in this area here of this chart. For aliphatic hydrocarbons at 900 parts per million, a supplied air respirator in continuous flow mode provides an APF of 25. So that's this one right here, the very top. Whoops. For me, that would be the way to go in this situation. And one of the main reasons for me this would be the way to go is because it would allow the use of loose-fitting hoods. And you're not going to have workers with beards complaining and not wanting to wear the respirators. Sounds like something you shouldn't have to deal with, but that's a reality. The workers that you're going to find in a woodworking shop, commercial woodworking shop where they're using this material, a lot of those guys are going to have beards. Hell, some of the women may have beards in that environment. And they're not going to want to shave them off. And they don't have to if you choose this particular respiratory protection device. Again, if you really needed to, you could go up to a self-contained breathing apparatus with a full face piece, which gives you an APF of 50. Or you could go up to a supplied air respirator with a full face piece, also giving you an APF of 50. But at this concentration, 900 parts per million, you don't need to. And I from a practical standpoint, that continuous flow mode supplied air respirator with a loose hood is going to be more effective. So we know what we need to deal with aliphatic hydrocarbons at 900 parts per million. But we do have 2 other hazardous constituents. We have the zirconium and we have the methyl ethyl ketoxime that we need to consider also. So we need to go back to the NIOSH Pocket Guide and find information for zirconium 2 ethyl hexanate. And when we do that search, there are no results in the Pocket Guide. So we got to do some additional research. And from that additional research, we learned that this constituent is only really hazardous if you get it in your eyes. You don't want to get it in your eyes. It will eat your eyes up. but it is not a significant inhalation hazard, especially when the material we're using by volume is only 0.4% zirconium. If it was a higher percentage and there was a potential for vaporization of that material, then maybe. But there is the research during this process, there's no significant inhalation hazard. So we can pretty much forget this as for when it comes to respirators. Now, we would want to make sure our workers understood the eye hazards and even the skin hazards. You don't want to get it on your skin. You definitely don't want to get it in your eyes. So, but in inhalation respirators, it's not applicable. Now we need to check out the methyl ethyl ketoxene in the NIOSH database. When we do that, no results. We do some additional research for methyl ethyl ketoxene, and we find out that this is also called 2-butanone oxime and is closely related to methyl ethyl ketone. Now we go back to the NIOSH database and we check out 2-butanone in the NIOSH database, and we do find some results. And here's the information. Oh, let me fix that. Ignore that. These are the results for 2-butanone, methyl ethyl ketoxene. And what we find, well, let me back up. I'm getting ahead of myself. Okay, we need to determine the concentration of this particular chemical. For our purposes, let's assume 75 parts per million. Remember, this is only 0.4% by volume of the Minwax that was being used. Just less than 1% of the Minwax was this 2-butanone or the methyl ethyl ketoxene. So let's assume 75 parts per million. When we do our calculations, we do our sampling, our monitoring, 75 parts per million. So now we need to find a respirator that will work with this substance at 75 parts per million. And these are our options up to 3,000 parts per million. But remember, we got the other constituent also. We need to compare the respirator requirements for both of those two constituents that are an inhalation hazard. So let's do that on the next page. Here we go. We've got petroleum distillates up here, and we've got 2-butanone down here. When we look at these numbers, or this information, we're at 900 parts per million here, so we need to be in this category. And we've already talked about this. We're going to go with any supplied air respirator operating in continuous flow mode. That would also work for the 2-butanone. For aliphatic hydrocarbons at 900 parts per million, supplied air respirator in continuous flow mode provides an APF of 25. This would allow the use of a loose-fitting hood. This would also work for methyl ethyl ketoxime at 75 parts per million. And let's just verify that. Okay, up to 3,000 parts per million. Whoops. Up to 3,000 parts per million. There we are, APF 25, any supplied air respirator operated in continuous flow mode. That's the same that we need for working with the aliphatic hydrocarbons, the petroleum distillates. So that's the way to go. That's the decision I would make. I would use any supplied air respirator operated in a continuous flow mode. All right, let me just summarize this procedure that we went through for the Minwax problem. Information for Minwax is not in the NIOSH database. We had to look at the SDS to identify the hazardous constituents. NIOSH had information for 2 of the constituents. The third constituent was hazardous if in the eyes, but not an inhalation hazard, so that wasn't applicable to respirator selection. We chose the best respirator based on the NIOSH recommendations for aliphatic hydrocarbons and methyl ethyl ketoxime. Again, this was a case of detective work and research. Yeah, I went through it pretty quickly, but it's not going to be that quick of a process. You may have to spend 3 or 4 hours, research, tracking down leads, and you may call someone that can give you some help. And some of you are thinking, Minwax polyurethane, I use that all the time, or my dad used that. That's not that bad of stuff. Yeah, it can be, especially if you're in a commercial cabinet shop where these guys are using it every day, all day, or even women. There are a lot of women cabinet makers. They probably don't have beards. Forget my joke earlier. But the men working in these commercial cabinet shops that use this, 5-6 days a week, 8-10 hours a day, they need protection from this stuff. It will affect their lives. There are harmful effects that can occur from it. And one other thing I'll say about Minwax or polyurethane or a lot of coatings, it's very difficult to use most types of ventilation when you're spraying or brushing or wiping on polyurethane, because you get that air moving, it picks up the dust and all of these fine particles. It will end up in your finish, and you can't have that. You can't have any air movement that you would get from a conventional ventilation system. If you have that air movement, it ruins the quality of your work. So that leaves you with personal protective equipment. That leaves you needing a loose-fitting hood with an air-supplied respirator in the continuous flow mode. All right, we're going a little long on this one, but I've been short on some other ones, so it's evening out. A couple of other respirator selection issues, and then we will end this module. Workers are entering a tank. The tank contains a non-flammable toxic vapor. They do not know the concentration of the vapor. We've talked about this. If you don't know the concentration, SCBA with an APF of 10,000 is what you need. Another situation. Workers are entering an empty grain silo. They do not know anything about the atmosphere in the silo. They don't have test instruments. They don't know anything. If you don't know anything and you're going into that area, you need an SCBA with an APF of 10,000. All right, that's the end of this module. When we come back in the next module, we'll talk more about choosing the correct cartridges and filters for your respirator.